As you tuck yourself in tonight and let your mind wander to distant places, I'd like to invite you to journey to a silent frontier we haven't visited in over half a century. The moon, not as we see it from Earth, hanging in the night sky like a pale, cold jewel, but as it appears from deep space, a world suspended in perfect stillness, waiting. This is the quiet journey of Artemis II, humanity's return to lunar exploration. Think of it as a slow, deliberate voyage through the profound quiet between worlds, a journey where every movement is measured and gentle, like the careful turning of pages in a book you read before sleep. As you drift off tonight, imagine floating alongside this spacecraft, not as an astronaut performing urgent tasks, but as a peaceful passenger observing Earth shrink to a blue marble, then watching the moon grow from a distant point to a full world. This isn't a story of frantic action, it's a reflective passage through the deep, dark ocean of space, where silence is the loudest sound and stillness becomes movement. To understand how we arrived at this quiet moment, imagine, if you will, a quiet summer night in 1969. The air is still, the world seems to be holding its breath, and somewhere a family gathers around a flickering TV screen. Through the static and the ghostly black and white images, a voice crackles through the speakers, a voice from another world. That's one small step for man, one giant leap for mankind. In that moment, Neil Armstrong wasn't just stepping onto the moon. He was stepping into our collective imagination, becoming part of a story that humanity had been telling itself for thousands of years. Those first footprints in the lunar dust weren't merely physical impressions, they were markers in time. They represented the culmination of a feverish, almost desperate competition between two superpowers, a race born from Cold War tensions and national pride. But beneath that political surface, something deeper was happening, something magical. When Armstrong and Buzz Aldrin planted the American flag in the Sea of Tranquility, they were also planting something in our consciousness, the realization that we could leave our cradle, that we could become creatures of more than one world. Think of the Apollo program as a great and sudden storm, a magnificent brief tempest of human achievement. Between 1969 and 1972, 12 men walked on the moon. They drove lunar rovers across that grey landscape. They played golf in 1/6 gravity. They collected rocks and dust, and they gazed back at Earth, that beautiful, fragile blue marble hanging in the blackness. Each mission built upon the last, like chapters in an epic novel of exploration. But here's what we sometimes forget. Those astronauts weren't just heroes or adventurers. They were scientists and explorers in the truest sense. They were collecting data, conducting experiments, and bringing back pieces of another world for us to study. The 842 pounds of lunar rocks and soil they returned have taught us more about our solar system than centuries of Earth-based observation could have. It's like having pieces of a puzzle that we didn't even know we were missing. Fragments that help us understand not just the moon, but our own planet's history too. Let me share something quiet and profound about those moon rocks. When scientists first examined them, they discovered something unexpected. These rocks were ancient, older than almost anything on Earth. Some were over 4 billion years old. They told a story of a violent beginning, of a young Earth colliding with another planet-sized body, debris coalescing into our moon. They revealed that the moon and Earth share a common ancestry, like siblings separated at birth. Studying these rocks has been like reading a diary of our solar system's earliest days, pages preserved in vacuum, untouched by wind or water or life. But Apollo wasn't just about geology. Those missions were laboratories for understanding how humans function in space, how our bodies respond to weightlessness, how our minds handle the psychological strain of being so far from home, with Earth reduced to a distant jewel in the window. The astronauts conducted medical experiments on themselves, tested equipment, and pioneered technologies that would become the foundation for everything that followed in space exploration. Now, you might be wondering, if all this was so valuable, so transformative, why did we stop? Why did we walk away from the moon after Apollo 17 in 1972 and not return for decades? The answer is complex, like a tapestry woven from many threads. First, there was the cost. The Apollo program was phenomenally expensive, adjusted for inflation. It would cost over $150 billion today. In the early 1970s, America was facing other pressing challenges: social upheaval, the Vietnam War, economic concerns. The political will that had propelled us to the moon began to wane. The race was won, the point was made, and attention turned elsewhere. Second, there was a shift in vision. Instead of returning to the moon, NASA began focusing on low Earth orbit, on building space stations where we could learn to live and work in space for extended periods. The Space Shuttle program was born from this vision, a reusable spacecraft that could ferry astronauts to and from orbit. This wasn't abandonment so much as it was a change in strategy, learning to walk before running again, mastering our own backyard before venturing farther out. But there's another reason, one that's more subtle and perhaps more human. After the initial awe of Apollo faded, a certain fatigue set in. The public became accustomed to moon landings. What had seemed miraculous became almost routine. TV ratings dropped. The wonder was replaced by expectation. It's like when you first fall in love. Every moment is electric, every detail vivid. But as time passes, that intensity naturally mellows into something quieter, deeper, perhaps even more meaningful, but less spectacular to outside observers. There were also scientific considerations. We had learned an enormous amount from Apollo, but we needed time to digest that knowledge. Thousands of researchers around the world spent decades studying those moon rocks, analyzing the data, publishing papers. Sometimes in exploration, the journey outward must be followed by a journey inward, a period of reflection and understanding. And then there's something I think we don't talk about enough: the psychological distance. The moon is far, not just in miles, about 240,000 on average, but in experience. It's a place of extreme silence, extreme temperatures, extreme emptiness. The astronauts who went there reported a profound sense of isolation, even as they worked together. Going to the moon isn't like taking a long flight, or even like earlier sea voyages. It's stepping completely outside our biosphere, outside the protective embrace of Earth's atmosphere and magnetic field. That kind of journey requires not just technological readiness, but psychological and cultural readiness too. So for 50 years, the moon remained quiet. No human footprints disturbed its dust. The flags planted by Apollo astronauts faded to white in the relentless ultraviolet radiation. The landing sites became time capsules perfectly preserved in the vacuum. And back on Earth, we looked up at that familiar face in our night sky and remembered, but didn't return. During this long hiatus, something interesting happened though. Our understanding of the moon deepened even without new human visits. Robotic missions from various nations, the United States, Russia, Europe, China, India, Japan, continued to orbit the moon, map its surface, study its composition. We discovered water ice in permanently shadowed craters at the poles. We learned about the moon's thin atmosphere, its tectonic activity, its complex magnetic history. We found evidence that the moon isn't quite as dead as we once thought. Think of it this way: if Apollo was our first breathless introduction to the moon, a whirlwind romance, then these past 50 years have been the slow, careful courtship, getting to know each other properly. Learning the nuances, understanding not just the broad strokes, but the fine details. And all this time, something was stirring. A new generation grew up looking at moon rocks in museums, watching archival footage of Apollo, wondering, when do we go back? And more importantly, why do we go back? The answers to those questions began to crystallize into a new vision, one that would eventually become the Artemis program. But that is a story for another night. For now, let the ghostly images of Apollo linger in your mind. The grainy footage, the crackling audio, the first human footprints on another world. Remember that for a brief, brilliant moment half a century ago, we reached out and touched the moon. And then we paused, not because we had lost our way, but because we needed to understand what that touch meant. Rest now with these whispers from the past. Imagine for a moment that you've walked away from something you love. Perhaps a garden you tended, a painting you started, a book you were reading. Years pass, maybe decades, and you feel a gentle tug, a quiet longing to return. Not to relive the past exactly, but to see what new growth might have sprung up in your absence, what fresh perspectives you might bring with the wisdom of years. This, in a way, is humanity's relationship with the moon. We visited, we left footprints and flags, and then we stepped away. For 50 years, the moon has been a memory, a black and white photograph in the album of our collective history. But now something is stirring, a quiet awakening. This is the story of Artemis and the gentle, persistent reasons why we are choosing to return. Our first reason is perhaps the most fundamental: to learn. The moon is an untouched diary of the solar system. Every crater, every rock, every layer of dust holds a story billions of years old, waiting to be read. Think of it this way: Earth is like a bustling city that's been constantly remodeled. Volcanoes erupt, continents shift, rain and wind erode the landscape. Life grows and decays. Our planet's ancient history has been largely paved over by its own vibrant activity. The moon, by contrast, is a perfectly preserved archaeological site. It has no atmosphere to wear away its features, no tectonic plates to shuffle its surface, no water to wash away the evidence. It has sat in stillness, recording the bombardment of asteroids, the eruptions of its own ancient volcanoes, and even scientists believe material flung from Earth during colossal impacts in our planet's youth. By going back, we are opening a time capsule. We're not just going to the moon, we're traveling back in time to understand our own origins, the violent birth of the Earth-Moon system, and the conditions that may have led to life itself. But this quest for knowledge isn't just about looking backward. It's profoundly about looking forward to a place even farther away: Mars. The moon is our cosmic training ground, our backyard where we can practice for the great journey. A trip to Mars is an expedition of staggering complexity and risk. The journey there takes months, not days. Once you arrive, you're hundreds of millions of kilometers from home, with communication delays of up to 20 minutes each way. There is no quick rescue. Every system must work. Every procedure must be mastered. The moon offers us a profoundly valuable dress rehearsal. We can test new life support systems in a harsh, airless environment. We can practice landing larger, heavier payloads with pinpoint accuracy. We can learn how to live off the land, a concept called in situ resource utilization. This means using what you find at your destination to survive on the moon. That might mean extracting water ice from permanently shadowed craters at the poles to make drinking water and rocket fuel. It might mean using the lunar soil, called regolith, to 3D print habitats or shield against radiation. Mastering these skills on the moon, just 3 days from home, is infinitely safer than trying them for the first time on a years-long mission to Mars. The moon is not the final destination. It is the necessary stepping stone, the quiet proving ground for humanity's next giant leap. Then there's the matter of partnership. The original Apollo program was a sprint, a breathtaking race between two superpowers, driven by competition and the tension of the Cold War. Artemis is something different. It is designed to be a marathon, a sustainable journey, and it is being built on a foundation of international cooperation. More than 24 nations have signed the Artemis Accords, a set of principles for peaceful and transparent exploration. The European Space Agency is building the service module that will power the Orion spacecraft. Canada is contributing a sophisticated robotic arm. Japan is planning a pressurized rover for astronauts. This is no longer a solo endeavor. It is a global project. Why does this matter? Because when nations work together on a challenge as difficult and inspiring as exploring a new world, they build bonds that transcend earthly politics. They share technology, they share risk, and they share the wonder of discovery. They create a model for how we might tackle other grand challenges here on Earth. The Artemis program whispers a hopeful message that when we look up at the same moon, we can remember that we share the same fragile planet below. This cooperation also fuels another powerful engine for return: innovation. The technical challenges of going back to the moon and doing so to stay are driving breakthroughs that will ripple through our lives on Earth. The need for more powerful yet sustainable rocket engines pushes materials science. The quest for reliable life support in a closed environment advances water recycling and air purification technology. The development of new spacesuits that are more flexible, more durable, and capable of operating in the extreme temperatures and abrasive dust of the moon will inspire improvements in protective gear for firefighters, divers, and workers in hazardous environments here at home. Even the software and autonomous systems needed to guide complex spacecraft and manage missions will find applications in transportation, medicine, and industry. Space exploration has always been a catalyst, a quiet hum in the background that pushes the entire orchestra of human technology to play a new, more advanced symphony. The money spent doesn't vanish into the void. It invests in brighter minds, better tools, and new solutions that eventually find their way back to Earth, improving lives in thousands of small, often unnoticed ways. And finally, there is a reason that is harder to quantify but equally important: inspiration. For a generation that has only known spaceflight through history books or the routine trips to the International Space Station, Artemis offers a new chapter of awe. It will put human faces, diverse faces, back in the spacesuits. The Artemis 2 crew that will fly around the moon, the first people to travel that far since 1972, includes the first woman, the first person of color, and the first Canadian on a lunar mission. Their journey will be broadcast, shared, and experienced by millions. A child looking up at the night sky will no longer just see a distant rock. They will know that right now, at this moment, people are traveling there. That knowledge is a spark. It can ignite a passion for science, for engineering, for exploration, for the simple act of looking upward and wondering. It reminds us that we are a species capable of extraordinary collaboration and courage. In a world often focused on division and immediate problems, the quiet, steady progress of a rocket leaving for the moon is a gentle counter-narrative. It says we can still do great things together. We can still reach for the sublime. So why are we returning? We return to read the solar system's oldest stories etched in the lunar dust. We return to practice for the longer voyage to the red plains of Mars. We return to work alongside partners from around the globe, building a new model of cooperation. We return to solve difficult problems, sparking innovations that will warm our lives back home. And we return to feel that sense of wonder again, to give a new generation their own moon to reach for. Artemis is not a repetition of Apollo. It is an evolution. It is the awakening of a sustained human presence beyond our home world. It begins not with a sprint, but with a deep collective breath and the first deliberate steps of a journey meant to last. And that journey now takes shape in a specific vessel, with a specific crew, on a specific mission. The quiet, pioneering flight of Artemis 2. Now that we understand what the Artemis 2 mission represents, this bridge between past and future, this gentle reawakening, let's explore the journey itself. This isn't just a symbolic flight, it's a meticulously planned, decade-in-the-making symphony of engineering, physics, and human courage. Artemis 2 is what we call a circumlunar mission. Think of it like taking a long, looping road trip around a beautiful national park. But instead of mountains and forests, the park is our moon, and the road stretches nearly 250,000 miles through the vacuum of space. The mission will last approximately 10 days. For those of us on Earth, 10 days might pass in a blur of routine, commutes, meals, sleep. But for the 4 astronauts aboard Orion, those 10 days will contain lifetimes of experience. They will launch from the same historic pad at Kennedy Space Center that sent Apollo missions skyward, riding the most powerful rocket ever built, the Space Launch System, or SLS. This rocket is a quiet giant. It doesn't roar with the raw, crackling fury of the Saturn V. Its sound is described as a deeper, more resonant rumble, a bass note to history's tenor. It will push the Orion capsule out of Earth's grasp with such force that the astronauts will experience about 4 times the normal pull of gravity, pressed back into their seats as if by a firm, steady hand. Once free of Earth, Orion will separate and begin its solo voyage. Its first major maneuver is something called the translunar injection, or TLI. This is the engine burn that changes their path from orbiting Earth to arcing gracefully toward the Moon. Imagine you're on a merry-go-round, holding a ball. If you simply let go of the ball, it flies off in a straight line tangent to the circle. The TLI burn is like giving that ball an extra precise push at just the right moment, so it doesn't just fly off randomly, but is aimed perfectly to intersect with the Moon's distant orbit. It's a ballet of momentum and timing, executed by computers with inhuman precision, guided by human minds back on Earth. For the next several days, the crew will be in what's called the outbound coast phase. They'll be traveling, but not under power. They'll be gliding silently along the curve of a gravitational highway. Think of it like a roller coaster car that has been pulled to the top of the first hill. After that initial launch and that TLI push, the rocket's work is mostly done. Now the car is coasting down the other side of that hill, trading the height it gained for speed, following the invisible tracks laid down by gravity itself. They are falling ever so gracefully toward the Moon. Their trajectory is not a straight line. It's a long elliptical arc, a shape called a free return trajectory. This is one of the mission's quietest revolutions in safety thinking. This specific path is chosen so that if, for any reason, Orion's main engine fails completely after the TLI burn, the spacecraft will simply loop around the Moon and be naturally slung back toward Earth by gravity alone, like a boomerang returning to the hand. No extra engine burns would be needed for a basic emergency return. It's a built-in safety net woven into the very fabric of their flight path. It's a lesson learned from decades of spaceflight. Hope for the best, but let the laws of physics plan for the rest. About 4 days after launch, they will arrive at their closest point to the Moon. They won't be landing. They won't even be entering a tight orbit around it. Instead, they will perform a lunar flyby, skimming just a few thousand miles above the ancient cratered surface. This is the heart of the mission's quiet significance. For the first time in over 50 years, human eyes will behold that grey world up close, not through a telescope lens or on a screen, but through a spacecraft window. They will see the Terminator line, the sharp division between lunar day and night, creeping across the plains. They will see the Earth rise over the lunar horizon, a breathtaking marble of blue and white suspended in the blackness. This moment, the Earthrise, was captured photographically during Apollo 8, and it changed our perspective forever. Seeing our fragile home from that distance made it seem both infinitely precious and terribly small. The Artemis II crew will experience that view in real time with their own eyes. They will be farther from Earth than any humans have ever been, venturing thousands of miles beyond the distance of the Apollo missions. Their perspective will be unique. They will be at a point in space where they can take in the entire disk of our planet in one glance, a sight no Apollo astronaut ever saw. After this intimate pass by the moon, gravity will begin to pull them back. They will start the inbound coast, the return leg of their journey. They'll have another several days of quiet transit through the cislunar space, the region between Earth and Moon. During all this coasting time, the spacecraft will be largely silent. The constant hum of life support systems will be there, of course, a mechanical whisper keeping them alive, but outside there is no sound. No wind rush, no engine rumble, just the profound, absolute quiet of space. The astronauts will have time, a luxury rarely afforded in modern life, to look, to think, to float by a window and simply observe. Their tasks during the flight will be a blend of the critical and the symbolic. They will be thoroughly testing the Orion spacecraft systems. Is the navigation accurate? Do the communications work perfectly at such distances? How does the crew module handle the thermal extremes, from the blistering sunlight to the shadowed cold? They will test the performance of the service module provided by the European Space Agency, which provides power, propulsion, and water. This international collaboration is another quiet evolution. The lunar program is no longer a national solo effort, but a global orchestra. The crew will also test something very human-centric, the Artemis suit system. They won't do a spacewalk, but they will spend time in the new, more flexible lunar suits within the cabin, checking mobility and comfort. It's a rehearsal for the steps that will come on Artemis III, and they will conduct a suite of science and medical experiments, collecting data on how the deep space environment, particularly radiation beyond Earth's protective magnetic field, affects the human body. This data is the quiet, unglamorous groundwork for future long-duration missions. Perhaps one of the most fascinating objectives is to test new communication methods. They plan to use the delay disruption tolerant networking protocol. Think of it like a celestial postal service for data. Instead of expecting an instant, continuous connection like a phone call, this system allows data to be bundled up, sent when a link is available, stored if it's not, and then forwarded along when the next link opens up. It's designed for an environment where signals can be blocked by planetary bodies or simply take minutes to travel the vast distances. It's infrastructure planning for a future where spacecraft and habitats are scattered across the lunar surface, needing to talk to each other even when Earth isn't in direct view. The return to Earth is a dramatic, fiery bookend to the quiet cruise. As Orion streaks back into the atmosphere at nearly 25,000 miles per hour, it will encounter friction that heats the protective shield to thousands of degrees, creating a blazing plasma sheath around the capsule, a man-made meteor. Parachutes, first small drogues to stabilize, then 3 massive main canopies, will bloom in the sky to slow the final descent to a gentle splashdown in the Pacific Ocean. Recovery teams will be waiting, just as they were for Apollo, to bring the crew and their precious capsule home. So why is this specific mission, Artemis 2, such a quiet revolution? Apollo was a sprint, a breathtaking, daring dash to the moon and back, driven by the fierce heat of geopolitical competition. Artemis is a marathon. Its pace is deliberate, its steps measured. Artemis 2 isn't about planting a flag or taking a giant leap. It's about proving we can walk the path again, and that we can walk it safely, sustainably, and together. It's about relearning the skills we let fade, but with all the technological wisdom of the 21st century at our fingertips. It's about building confidence in new machines and new methods. It's the crucial dress rehearsal before the main performance. In the grand narrative of lunar exploration, if Apollo 8 was the moment we first read the opening chapter aloud, and Apollo 11 was the climax, then Artemis II is the thoughtful, careful rereading of that opening chapter, making sure we understand every word, every nuance, before we begin writing the next volume of the story. It is patience. It is preparation. It is the deep breath before the next step. And that step, of course, depends entirely on the people taking it, which brings our focus to the 4 individuals who will turn this detailed flight plan from lines on a chart into lived experience. Now, let's meet the 4 people who will be making this journey. If you think about space exploration as a symphony, each mission needs different instruments playing together in harmony. The hardware and the rockets are the percussion section, the powerful, thundering foundation. The mission controllers are the string section, keeping everything connected and in tune. But the crew themselves, the astronauts, they are the woodwinds and brass. They carry the melody. They give voice to the mission. And for Artemis 2, that melody will be carried by 4 extraordinary individuals who have spent their entire lives preparing for this moment, though none of them knew they were preparing for exactly this. First, there's Reed Wiseman. He'll be commanding this flight. Think of him as the conductor of this small, 4-person orchestra floating through space. He's been in space before, spending 165 days aboard the International Space Station back in 2014. But that experience, as profound as it was like practicing a complex piece of music in a small, familiar concert hall. This will be different. This is taking that symphony out into the wilderness, far from any stage or audience. Reed was a Navy pilot before he became an astronaut, flying combat missions from aircraft carriers. There's a particular kind of calm that develops in people who have had to make life or death decisions while moving at hundreds of miles per hour, with the ocean waiting below if something goes wrong. That calm, that steady focus will be the bedrock of this crew. He's not just a pilot. He's a leader who understands that in the silence of deep space, leadership isn't about giving orders. It's about listening. It's about ensuring that the quiet hum of the spacecraft is matched by the quiet confidence of the people inside it. Sitting to his right in the pilot's seat will be Victor Glover. Victor's journey to this seat is a story of quiet, persistent firsts. He was the first black astronaut to live aboard the International Space Station for a full 6-month expedition. And now, he will be the first black astronaut to pilot a spacecraft to the moon. If you think about the history of exploration, for so long, the view from the cockpit, the view from the capsule window, was a very specific, limited perspective. Victor's presence in that pilot's seat expands that view. It says the journey belongs to everyone. His background is in engineering and test piloting. He flew the FAA Twin test pilots, have a unique relationship with machines. They don't just operate them, they converse with them. They listen to the creaks, the vibrations, the subtle shifts in tone that a machine makes. They develop a feel for it, like a musician feels their instrument. On this flight to the moon, Victor will be listening to Orion, feeling its responses. His hands on the controls not just to steer, but to guide a companion on a long, delicate voyage. Then we have Christina Koch. She holds the record for the longest single spaceflight by a woman, an astonishing 328 days in orbit. That's nearly 11 months. To spend that much time away from Earth, from fresh air, from the feeling of rain or the sound of wind in trees, requires a profound inner resilience. It's a kind of mental and emotional endurance that is hard to fully comprehend from down here. Imagine reading a very long, very complex book, but you can never put it down, and you're also one of the characters in it. That's what a long-duration spaceflight is like. Christina is a scientist and an engineer. She helped repair critical equipment on the space station with her own hands. She understands the intimate details of the machines that keep humans alive in the void. For Artemis 2, she will be a mission specialist, the eyes and hands for countless scientific observations and system checks. But more than that, she brings the wisdom of someone who has already heard the deep, whispering silence of space for almost a year. She knows what that does to a person. She knows how to find stillness within it. And finally, rounding out this crew of 4 is Jeremy Hansen. He is from Canada and he represents the international spirit of this new chapter. Jeremy is a fighter pilot from the Royal Canadian Air Force, but he has never been to space. Artemis 2 will be his his first flight. There's something beautifully poetic about that. The last time humans went to the moon, every single person who went had never been before. They were all taking that leap for the first time. In a way, Jeremy connects this new journey directly back to that original spirit of discovery. He is the newcomer, filled with that fresh wonder. While his crewmates have seen Earth from orbit, he will experience that breathtaking view, and then the view of the moon growing from a distant disk to a looming world for the very first time. His perspective will be unfiltered by previous experience. It will be pure, immediate awe. In a crew that balances experience with newness, Jeremy is the essential ingredient of fresh eyes. So that's them, Reed. The steady commander with the deep space gaze. Victor, the pilot who listens to the song of his machine. Christina, who carries the quiet strength of nearly a year in orbit. And Jeremy, the first-time explorer linking our past to our future. But who are they really when you strip away the titles and the records? They are 4 people who have chosen to sit inside a small capsule attached to the most powerful rocket humans have ever built, and let it throw them into a void where help is days away. They've made this choice knowing the risks, honoring the history, and facing a loneliness that is almost unimaginable. What does it feel like to be the first in over 50 years to make this trip? They are standing at a doorway that has been closed for a lifetime. The last people to go through it, the Apollo astronauts, are now in their 80s and 90s. Their stories are history books. Their footsteps are frozen in lunar dust that hasn't been disturbed in decades. For the Artemis 2 crew, this isn't just a mission. It's an act of reconnection. They are reaching across time to shake hands with those Apollo pioneers to say, "We remember, we are coming back." But they are also doing something new. Apollo was a sprint, a brilliant, daring dash to the finish line. Artemis is the beginning of a stay. This crew won't land, but their journey paves the way for those who will. They are the first to walk down a path that many will follow. Think about the quiet courage that requires. It's not the dramatic, fist-pumping courage of movies. It's the quiet courage of meticulous preparation. It's the courage of trusting your training and your teammates when you are farther from home than any human has been since 1972. It's the courage to be a placeholder for all of humanity's curiosity, to carry our collective gaze with you into the deep. They will experience things no one has experienced in generations. The sight of the entire Earth, a blue and white marble, shrinking to the size of a coin held at arm's length. The complete blackness of space, uninterrupted by atmosphere, where the stars don't twinkle, they just burn, steady and cold and infinite. The eerie silence of a spacecraft coasting, engines off with nothing but the hum of fans and the beat of 4 hearts. They are not superhuman, they get nervous. They miss their families. They wonder what they will see and how it will change them. In their interviews, they speak with a calm humility. They talk about the team, about the mission, about the honor. They rarely dwell on themselves. That, perhaps, is the most telling quality of all. The journey is bigger than they are. They are its temporary custodians. So as we listen to the gentle details of their mission, remember the human heart at the center of it all. 4 people, breathing in sync with their machine, looking out windows at a site forgotten by living memory, and whispering, perhaps just to themselves, "We are going back." And as their spacecraft finally breaks free of Earth's embrace, sailing into the profound quiet between worlds, they will leave behind not just our atmosphere, but the very context of life as we know it. Imagine you're floating, gently suspended, in a space where there is no up, no down, no forward, no back. You're simply existing. That is what the crew of Artemis 2 will experience as they journey further from Earth than any human since the last Apollo mission. We've talked about the launch, that spectacular roar of energy that lifts them from our world. But now, once the rockets have fallen away, once they've cleared the pull of our atmosphere, something extraordinary happens. The noise stops completely. You might think space is silent because there's no air to carry sound. And that's true scientifically. But this silence is deeper than just the absence of vibration in your ears. It's a profound, almost physical quiet. Inside their capsule, there will be the gentle hum of life support systems, the soft beeps of computers, the quiet murmur of conversation. But outside, beyond that thin metal skin, an infinite ocean of nothing. No wind, no waves, no rustle of leaves, not even the distant, comforting murmur of a city at night. It's a silence so complete. It has weight, it has presence. Think of the quietest place you've ever been. A deep cave, perhaps, or a remote mountain peak at night. Now multiply that by 1,000, then subtract from it any sense of a horizon, any solid ground beneath your feet. That is the silence of deep space. It's not empty, it's full of a quiet so absolute it becomes its own kind of sound, a ringing in the soul rather than the ears. And as they travel, as Earth shrinks behind them, the experience becomes even more meditative. They are moving at thousands of miles per hour, yet with no rushing air, no vibration through a frame. There is no sensation of speed at all. It's like being on the calmest, stillest lake imaginable, while somehow knowing you are crossing an entire ocean. The only way they can truly perceive their motion is by watching the world outside their windows. And what a view that will be. Picture this. You're floating by a window, not sitting, not standing, just floating. And you look back. There, hanging in the black velvet of space, is our entire world. Not a map, not a photograph, but the living, breathing planet. You see the swirl of white clouds over a deep blue ocean. You see the brown and green tapestry of continents with no borders drawn upon them. You see the delicate, shimmering aura of our atmosphere, that thin, precious blanket of air that protects everything we know and love. And as you watch, it grows smaller, not quickly, but steadily. From the size of a basketball held at arm's length to a grapefruit to an orange. This is a perspective that very, very few humans have ever had. To see your entire home, your entire history, your entire species contained in a single beautiful sphere, drifting further into the distance. Astronauts who have experienced it speak of it in almost spiritual terms. They call it the overview effect, a sudden deep understanding of the fragility and unity of our planet. All the noise down there, the politics, the conflicts, the busy hustle of daily life, it all dissolves into silence from this distance. What remains is just a garden. A vibrant, lonely, stunningly beautiful garden in the vast dark. And as Earth shrinks, something else grows, the moon. It begins as a bright crescent, then a half, then a full disk. But unlike our view from Earth, this is not the gentle, grey, familiar face we know. From this side, as they swing around the far side of the moon on their figure-8 path, they will see the lunar surface in its raw, ancient glory. Sunlight will blaze across craters and mountains, creating shadows so sharp and black they look like holes cut into the universe. There will be no soft blue glow of Earthlight here. This is the moon in its own domain, stark, magnificent, and utterly silent. For a period of time, as they pass behind the moon, Earth will disappear entirely. They will be, for the first time in human history, on this particular path, completely cut off from home, no direct radio contact, no sight of that blue marble. Just the crew, their spacecraft, and the immense cratered landscape of another world outside their window. In that moment, they will be the most isolated humans in existence, farther away from home than anyone has been for over 50 years. What does that isolation feel like? Psychologically, it's a journey within a journey. There's a camaraderie that forms, a bubble of human warmth inside the technological shell. They will work, they will eat, they will sleep, they will share stories, they will look out the window together and simply wonder. But there will also be moments of profound inner quiet, moments where each of them is alone with their thoughts, floating in their sleep restraints, listening to the quiet hum of the ship and the much, much louder silence of the universe beyond. It's in these moments that the journey becomes meditative. Without gravity, your body relaxes in ways it never can on Earth. Your spine stretches, your joints float free. There's a physical peace that mirrors the mental expanse. You might think such emptiness would be terrifying, and perhaps at first it is for some. But many astronauts describe it as ultimately peaceful. It's a removal of all the clutter, all the noise, all the constant gravitational pull of earthly concerns. You are reduced to your essence, a thinking, observing being, adrift in an ocean of stars, and the stars themselves. They are different out there, with no atmosphere to blur and scatter their light. They don't twinkle. They are fierce, steady, brilliant pinpricks of light. Millions upon millions of them, with no city glow to wash them out. The Milky Way isn't a faint smear across the sky. It's a torrent of light, a river of suns so dense it looks almost solid. Against this backdrop, the moon is a giant, detailed, charcoal gray landscape, and Earth is a tiny, exquisite sapphire. This sensory experience, the visual grandeur, the profound silence, the physical weightlessness, creates a state of mind that is hard to replicate on Earth. It's a combination of awe, humility, and a strange, quiet joy. They are not conquering space. They are visitors, gentle and temporary, passing through a cathedral of such scale that it defies human comprehension. Their journey is a long, slow arc, a gentle cruise, not a frantic race. There will be days of this peaceful transit, of watching the two worlds change their apparent sizes in the windows, of checking systems, of exercising to keep their bodies ready, of simply being. It is, in many ways, the ultimate mindful journey. Every moment is present. Every view is unique. Every breath is a reminder of the incredible, fragile system keeping them alive in the void. They will carry the silence with them. Not just the acoustic silence, but the silence of being untethered. The silence of perspective. When they finally fire their engines to swing back toward Earth, when that blue marble begins to grow once more in their windows, they will be different people. They will have seen the overview. They will have felt the depth of the quiet. They will have been for a few days citizens of deep space. And as they turn for home, their minds already beginning the transition back to our world, they carry more than memories. They carry data. They carry the living, breathing experience of the human body and mind in this extreme environment. Because this quiet journey isn't just a sightseeing trip. It has a very precise, gentle purpose, one that lays the groundwork for everything that comes next. As the Orion spacecraft drifts further from Earth, entering what's called the distant retrograde orbit around the Moon, it's not just a journey through physical space, it's also a journey through scientific understanding. This quiet voyage carries with it whispers of discovery, questions that can only be answered when you venture far enough away to gain a different perspective. And this is what Artemis 2 is truly about when we look beyond the spectacle. It's a carefully planned scientific expedition where every moment, every instrument reading, and every observation serves a purpose. You see, this mission serves as what engineers might call a pathfinder, a careful test of all the systems that will later support lunar landings. Think of it like a dress rehearsal for a major theater production, but instead of actors on a stage, we have astronauts in a spacecraft, and instead of lines to be memorized, we have complex procedures to be tested under real conditions. The Orion spacecraft itself is undergoing the most thorough evaluation possible. Every system, from life support to navigation, from power generation to communication, will be pushed to operate in an environment it was specifically designed for: deep space. One of the most critical tests will involve what's called propulsive maneuvers. This is essentially the spacecraft's ability to change its course using its main engine. Now, you might wonder why this matters so much. Imagine you're driving a brand new car on its very first long journey. You'd want to know how the engine performs at different speeds, how the brakes respond when you need to slow down, and how the vehicle handles turns. In space, these maneuvers are far more delicate. They're not just about changing direction, but about doing so with incredible precision. A slight miscalculation could mean missing an important gravitational assist, or in a worst-case scenario, failing to return to Earth properly. So during Artemis II, the crew will perform several carefully timed engine burns to prove that the spacecraft can reliably execute the complex orbital ballet that future lunar missions will require. But the scientific whispers aren't just about machinery. They're also about us, about what happens to the human body when it ventures so far from home. This will be the first time humans travel beyond low Earth orbit since 1972, and medicine has advanced tremendously since then. We have new questions and new tools to answer them. Consider radiation, the invisible energy that permeates space. Here on Earth, we're protected by our atmosphere and magnetic field, like a natural umbrella shielding us from a cosmic rain. But in deep space, astronauts are exposed to different types of radiation that we don't fully understand. During Apollo missions, radiation exposure was monitored, but our understanding was limited. Now, with Artemis 2, scientists have designed experiments to measure not just how much radiation the crew receives, but how different types of radiation affect biological systems. Tiny samples of human cells and tissues are flying along with the astronauts, sealed in special containers to see how they react to the space environment. It's like sending microscopic messengers ahead of us to report back on conditions we'll eventually experience for longer periods. Then there's the question of vision. Many astronauts returning from the International Space Station report changes in their eyesight, a phenomenon we're only beginning to understand. The prevailing theory involves how fluids shift in the body without gravity's constant pull, potentially affecting pressure in the eyes and brain. But the International Space Station is only about 250 miles up, still within Earth's protective embrace. Artemis 2 will take humans much further, giving us our first look at how these physiological changes might differ in deep space. The crew will perform regular eye exams and other medical checks, creating a detailed map of how the human body adapts or struggles to adapt to an environment so different from our evolutionary home. Perhaps one of the most elegant experiments aboard Orion doesn't involve the astronauts directly at all. It's called Callisto, named after one of Jupiter's moons, and it's a technology demonstration that might feel strangely familiar. Callisto is essentially a version of Amazon's Alexa voice assistant, modified to work in space. Now, this might sound like a gimmick, bringing consumer technology to a multi-million-dollar spacecraft, but the purpose is deeply practical. Future long-duration missions will need efficient ways for crews to interact with their spacecraft systems without being overwhelmed by switches, buttons, and complex interfaces. Voice control could allow astronauts to request information, control non-critical systems, or even access procedural guidance hands-free while they're busy with other tasks. It's about reducing cognitive load, about making the spacecraft environment more intuitive and less demanding on human attention. During the mission, the crew will test Callisto by asking it to perform various functions, from controlling the cabin lights to retrieving information from onboard databases. Engineers back on Earth will be listening carefully, not just to see if the technology works, but to understand how humans naturally want to interact with an AI assistant in the unique environment of a spacecraft. The questions themselves, how astronauts phrase their requests, what they ask for most frequently, even the tone they use, will provide valuable data about human-machine interaction in isolation. It's a whisper of how future space habitats might operate, where the walls themselves might listen and respond. Beyond the human-focused research, Artemis 2 carries instruments that will observe space itself. One experiment involves what's called space weather monitoring. Now you're probably familiar with weather here on Earth. Sunny days, storm systems, changing atmospheric conditions. Space has its own version of weather, driven not by water and air, but by the sun's constant outflow of particles and energy. Sometimes the sun is quiet, sometimes it erupts with solar flares and coronal mass ejections that send charged particles racing through the solar system. These space weather events can affect spacecraft electronics, pose radiation risks to astronauts, and even impact communication systems on Earth. By placing monitoring equipment on a spacecraft traveling to the Moon, scientists get a different vantage point. They can compare measurements taken far from Earth with those taken closer to home, helping them build better models of how space weather propagates through our solar system. It's like having weather stations not just in your backyard, but at various points along a highway stretching hundreds of thousands of miles. The more data points you have, the better you understand the system as a whole. All of these scientific whispers come together to answer a fundamental question. Can we not just survive, but thrive beyond our planet? Can we design systems reliable enough, understand human physiology well enough, and create living environments comfortable enough to make deep space exploration sustainable? Artemis 2 provides our first modern data points toward answering that question. The beauty of this approach is its gradual nature. Unlike the Apollo missions, which leaped directly to lunar landings, Artemis takes careful, measured steps. Artemis I was an uncrewed test of the basic spacecraft. Artemis II adds humans to the equation, but keeps them in orbit around the Moon rather than landing. Each mission builds on the last, answering specific questions before moving to the next challenge. It's the scientific method applied to exploration, forming hypotheses, testing them carefully, analyzing results, and then designing the next experiment based on what you've learned. As the Orion spacecraft reaches its farthest point from Earth, a distance where our planet appears as a small blue marble in the blackness, the crew will have time for reflection and observation. They'll see stars unobscured by atmosphere, the Moon's surface in stark detail, and Earth as a complete sphere hanging in the void. These moments aren't just poetic, they're psychologically important. Understanding how humans respond emotionally and cognitively to such profound vistas is itself a form of science. Do we feel isolation or connection when seeing our entire world as a single point of light? Does the experience change our perception of time, of distance, of our place in the cosmos? These are subtle questions, but ones that matter if we're to become a species comfortable living away from our home planet. The data gathered during these 10 days will flow back to Earth through delicate streams of radio communication, adding piece by piece to our understanding of space exploration. Some results will be immediate: engine performance numbers, radiation readings, medical vitals. Others will take longer to analyze. The biological samples need careful study back in laboratories. The psychological observations need contextual interpretation. The space weather patterns need comparison with other data sets. What we learn from distance isn't just about the technical details of keeping humans alive in space. It's about understanding the relationship between life and the universe it inhabits. Each measurement, each observation, each test result is a whisper from the frontier. telling us what's possible, what's challenging, and what we need to prepare for next. And as Orion completes its scientific work in lunar orbit, beginning the gentle curve back toward Earth, the questions naturally turn to what comes after this successful test. Having proven the systems, having gathered the data, having taken those first careful steps, what path do we follow from here? Imagine a mountain climber standing at base camp, looking up at a distant peak shrouded in mist. She can't yet see the summit, but she knows every step she takes now, every piece of equipment she tests, every breath she draws at this altitude is preparing her for the final ascent. This is where Artemis 2 stands in the grand journey back to the moon. It's not the final destination, but rather the crucial preparation that makes everything that follows possible. When you hear about Artemis III, which will return humans to the lunar surface for the first time since Apollo, it's easy to think of it as the main event, the climax of this story. But in truth, Artemis III stands on the shoulders of Artemis II. Every piece of knowledge gathered during that orbital mission, every system validated, every human reaction observed in that deep space environment becomes the foundation upon which the landing mission is built. Artemis 2 is the dress rehearsal where they work out all the kinks before the opening night performance. Think of it like building a house in a new neighborhood. First, you survey the land, checking the soil, the drainage, the access roads. You don't just start pouring concrete on day one. Artemis 2 is that survey. It's assessing how humans fare in that deep space environment beyond the protection of Earth's magnetic field. It's testing the life support systems for longer durations. It's practicing the maneuvers, the communications, the emergency procedures in the actual environment where they'll be needed. Only then, with that knowledge in hand, can they confidently build the permanent structures, the lunar landings, the habitats, the sustained presence. The path from Artemis 2 to Artemis III is like a carefully constructed bridge, with each component depending on the one before it. The Space Launch System rocket that will send Artemis III is essentially the same vehicle that launches Artemis III, but with modifications informed by what they learn. The Orion capsule will carry lessons from the first crewed flight into the design of the one that will dock with the lunar lander. Even the spacesuits the astronauts will wear on the moon are being tested and refined based on data from this mission. But perhaps the most fascinating aspect is what comes after Artemis 3. Because this isn't a one-time visit like Apollo was. This is about establishing something lasting, something sustainable. It's the difference between pitching a tent on a mountain for one night versus building a research station that can operate year-round. The vision extends to Artemis farther and beyond, where we'll begin assembling the Lunar Gateway, a small space station that will orbit the moon, serving as a waypoint, a research lab, and a staging point for missions to the surface. Imagine this gateway as a celestial port, a harbor in the sea of space. Ships, in this case spacecraft, can dock there, transfer cargo and crew, resupply, and then continue on to their final destinations on the lunar surface. It becomes a permanent foothold in deep space, a place where we can learn to live and work far from Earth for extended periods. And every lesson from Artemis to second feeds into this vision. The gateway won't be built all at once. It will grow module by module, capability by capability, much like the International Space Station did over 2 decades. But unlike the space station, which orbits just 250 miles above Earth, the gateway will be nearly 250,000 miles away at a special point called a near rectilinear halo orbit. This is a delicate, dancing orbit that takes advantage of the gravitational balance between Earth and the Moon, allowing spacecraft to enter and leave with minimal energy. It's like finding that perfect eddy in a river where a canoe can rest without paddling, conserving energy for the journey ahead. From this gateway, astronauts will descend to the Moon's surface in landers that are being developed right now by commercial companies. These aren't government-built vehicles like the Apollo landers. They're more like charter boats operated by private companies that NASA hires for specific missions. This partnership model is fundamental to the sustainability of the program. It spreads the cost, encourages innovation, and creates a true space economy, not just a government program. And the surface missions themselves will look very different from Apollo. Instead of landing, conducting a few experiments, planting a flag and leaving, these missions will begin establishing infrastructure. Think of early Antarctic explorers versus modern research stations. We'll see habitats that can support crews for weeks or months, rovers that can travel farther and carry more, power systems that can operate through the 2-week lunar night, and eventually the beginnings of resource utilization, learning to extract water from lunar ice or oxygen from the soil to live off the land as much as possible. All of this leads to perhaps the quietest, most profound long-term vision: Mars. The Moon becomes our training ground, our proving site, our stepping stone to the Red Planet. The technologies tested on the Moon, life support for long durations, radiation protection, in-situ resource utilization, autonomous operations when communications with Earth are delayed, these are all Mars technologies. The operational experience gained by crews living on the lunar surface for extended periods is Mars experience. The medical knowledge about how human bodies and minds adapt to partial gravity, isolation, and distance from Earth. This is Mars knowledge. It's like learning to sail. You don't start by crossing an ocean. You start on a lake, then coastal waters, then longer voyages. The Moon is our coastal waters, far enough to be challenging, but close enough that help could come if needed. Mars is the ocean crossing. And every hour the Artemis II crew spends in deep space, every system check, every medical monitoring contributes to that eventual ocean-going vessel. There's a beautiful continuity to this vision that often gets lost in the excitement of individual missions. Each flight builds on the last. Each discovery informs the next step. Each risk mitigated becomes a lesson incorporated into future designs. It's an incremental approach, patient and methodical, rather than the sprint of Apollo. And in that patience lies its strength and its sustainability. Consider how we build communities here on Earth. First come the explorers, mapping the territory. Then the settlers, establishing the first homesteads, then the infrastructure, roads, schools, markets, then specialization, farmers, craftspeople, doctors. The Artemis program follows this same organic progression. Artemis I was the mapping. Artemis II is the first scouting party assessing the conditions. Artemis III will establish the first homestead, and subsequent missions will build the infrastructure for a community. This quiet, step-by-step approach may lack the dramatic flair of a single giant leap, but it possesses a different kind of beauty, the beauty of deliberate growth, of building something meant to last, of creating not just a destination, but a pathway. It recognizes that returning to the moon isn't about proving we can do it once more, but about learning how to stay. And woven through all of this is an essential human element, the crews themselves. The astronauts of Artemis II aren't just test pilots, they're pathfinders in the truest sense. Their experiences, their observations, their very physiology in that environment becomes data that shapes everything to come. They are laying the human foundation upon which all the technical achievements will rest. So when you hear about Artemis II orbiting the moon without landing, remember that this isn't a lesser mission. It's the essential prerequisite. It's checking the water temperature before diving in. It's tasting the soup before serving the whole meal. It's making sure all the pieces work together in the actual environment before committing to the full endeavor. And as we look ahead to this quiet path to the future, to lunar landings, to the gateway, to sustained presence, and eventually to Mars, we can appreciate how each step depends on the one before it, how ambition must be tempered with preparation, how dreams must be grounded in data, and how the journey of 4 humans around the moon in Artemis to Tethys becomes the quiet, essential prologue to humanity's return to another world. But for now, let's return from this future vision to the present significance of this particular journey. Imagine, if you will, a quiet evening in your own neighborhood. The sun has set, the day's work is done, and you find yourself stepping outside to look up at the night sky. There, hanging like a luminous pearl in the darkness, is the moon. For millennia, human beings have stood in just this way, looking up at that same celestial companion, wondering about its nature, its meaning, its mysteries. And now, after more than 50 years, we are going back, not just with robotic probes or distant observations, but with people. Artemis II represents something more than a spacecraft mission. It's humanity's quiet step forward, a return to a place that has always been part of our collective imagination. What does it mean to return to the moon? On one level, it's a technical achievement of breathtaking scale, the culmination of decades of engineering, science, and planning. But if we look deeper, if we listen more closely to what this journey represents, we hear something else, a quiet cultural and philosophical milestone. The moon has never been just a rock orbiting our planet. It has been our calendar, our timekeeper, our muse. It has inspired poetry and music, shaped religions and mythologies, guided agricultural cycles and ocean tides. To return there is to reconnect with something fundamental to our human experience. Think of it like revisiting a childhood home after many years away. The physical structure might be the same, but you are not the same person who left. You bring with you all the experiences, knowledge, and perspective gained during your absence. When Apollo went to the moon in the 1960s and 70s, humanity was looking outward with the wide-eyed wonder of adolescence. We were proving what we could do, testing our limits, making our mark. Now with Artemis, we return as adults with more wisdom, more awareness of our fragility and responsibility, and a deeper understanding of why we go. This quiet step to the moon represents a shift in how we think about exploration. The Apollo missions were born in the heat of geopolitical competition, a race against time and another superpower. Artemis emerges from a different place, a collaborative, international effort focused on sustainable presence rather than symbolic flags. It's less about proving we can get there and more about understanding how we can stay, how we can learn, how we can build a future that includes the moon as part of our extended home. There's something profoundly human about returning to places that matter to us. We revisit the graves of loved ones, the sites of historical events, the landscapes of our personal memories. These returns are acts of remembrance, of continuity, of honoring what came before while making space for what comes next. Artemis II is humanity's collective return to a site of monumental achievement. It says, we remember what we accomplished. We honor those who made it possible, and we believe that journey continues. The quietness of this step is perhaps its most significant aspect. In a world filled with noise, with urgent headlines, constant notifications, and competing demands for our attention, Artemis II moves forward with a steady, persistent rhythm. It doesn't shout about its importance, it simply demonstrates it through meticulous preparation, international cooperation, and patient progress. In this sense, the mission becomes a metaphor for the kind of long-term thinking our species needs, projects measured not in news cycles, but in generations. Consider for a moment what the astronauts of Artemis II will experience as they orbit the moon, looking down at that ancient, cratered surface. They'll be following in the literal tracks of only 24 other human beings who have made this journey before them. They'll see the Earth rise over the lunar horizon, that breathtaking Earthrise photograph that changed our perspective forever during Apollo 8. But this time, they'll see a different Earth, one more crowded, more connected, more environmentally fragile than the planet those earlier explorers gazed upon. This difference in perspective is everything. The first lunar travelers saw our world as a beautiful, isolated marble in the void. Today's explorers see that same marble, but they carry with them the knowledge of climate data, biodiversity loss, and the intricate web of life that makes our planet unique in all the cosmos we've observed. Their view from lunar orbit becomes not just a beautiful sight, but a profound reminder of stewardship. The significance of return also lies in what we've learned during our absence. We've sent orbiters, landers, and rovers to the moon in the intervening decades. We've discovered water ice in permanently shadowed craters at the poles, a resource that could support long-term presence. We've mapped the moon in exquisite detail, studied its geology, and understood its relationship to Earth's own history. We return not as strangers, but as neighbors who have been studying the property next door, learning its contours and possibilities. This journey represents something essential about human nature, our need to explore, to understand, to push boundaries, but it's a more mature version of that impulse. It's not about planting a flag and moving on. It's about asking, what can we learn here that helps us on Earth? How can we test technologies for living in harsh environments? How can we use the moon as a platform for deeper exploration? How can we ensure that our expansion into space is done thoughtfully, sustainably, and for the benefit of all? There's a beautiful symmetry to this return happening now in the early decades of the 21st century. The original Apollo astronauts were mostly test pilots and engineers, products of the mid-20th century. The Artemis generation includes scientists, medical doctors, and a more diverse representation of humanity. They carry not just the technical knowledge of how to get to the moon, but the broader questions about why we go and what it means for our species. When you listen to the quiet progress of Artemis, the tests, the simulations, the careful preparations, you're hearing something fundamental. The sound of a civilization deciding to continue its outward journey, not in a burst of frantic activity, but in a sustained, purposeful movement. It's the difference between a sprint and a marathon. We're in this for the long journey now. This quiet step to the moon also represents hope, not the loud, dramatic hope of crisis moments, but the steady, persistent hope that builds futures. In a time when it's easy to focus on what divides us, Artemis brings nations together in common purpose. In an era of immediate gratification, it models patience and long-term thinking. When we're tempted to think only of today's problems, it reminds us to look toward tomorrow's possibilities. So as Artemis 2 prepares to make its journey, consider what it represents: continuity with our past, responsibility in our present, and hope for our future. It's humanity saying, we remember that we can do great things when we work together. We haven't forgotten how to look up and wonder. We still believe in journeys worth taking, even if they're difficult, even if they take time, even if they require patience. The moon has been our silent companion through all of human history. It watched as our ancestors painted on cave walls, built the first cities, wondered at the stars. It witnessed our first tentative steps beyond our atmosphere, our first footprints on another world. And soon it will welcome us back, not as visitors passing through, but as explorers returning home to a place that has always been part of our story. This quiet journey reminds us that progress doesn't always announce itself with fanfare. Sometimes it whispers in the careful calculations of engineers, in the patient training of astronauts, in the international agreements signed in quiet rooms. Sometimes the most significant steps are the ones taken steadily, thoughtfully, with eyes open to both the wonders ahead and the lessons behind. And as we prepare to take this next quiet step together, we might reflect on what it means to be a species that looks up at the night sky and wonders, and then sets about making the journey to find answers. And so they begin the gentle journey home. These travelers who touched the edge of our world. Their capsule, a tiny silver seed, drifts downward through the Earth's atmosphere, shedding speed and heat, becoming once more a vessel for the quiet air of our planet. They've left the stark silence of the moon behind, returning to the soft hum of our atmosphere, to the gentle pull of gravity that will cradle them once more. Think of their descent as like a leaf falling in autumn. It doesn't plummet, it drifts, it spirals, it finds its way back to Earth through currents it cannot see but can feel. And so our travelers drift back to us, guided by forces as ancient as the planet itself. They don't fight the descent, they surrender to it, trusting that the Earth will welcome them home. And perhaps this is where our story connects with yours tonight. For just as the Artemis crew surrenders to the gentle pull of gravity, you too are surrendering to the gentle pull of sleep. Their journey outwards and back becomes a reflection of your own journey from wakefulness into dreams, from the day's exploration into night's quiet harbor. Both journeys are circular, you see. The astronauts will return to where they began, carrying new perspectives from their voyage. And you will wake tomorrow having traveled through the night, returning to consciousness with the quiet wisdom sleep offers, exploration and rest, They're not opposites, but two rhythms of the same heartbeat, the outward breath of curiosity and the inward breath of restoration. So let their peaceful return become the rhythm of your own descent into sleep. Feel yourself floating gently downward, like a leaf, like a spacecraft returning to its home planet. The journey out is complete. The journey back has begun. And in this quiet space between, there is only peace. The capsule touches down in the ocean, bobbing gently on the waves, having completed its circle around the moon. And you too are completing your circle now, returning to the peaceful depths where all journeys find their rest. Sleep comes like gravity, gentle and certain, drawing you home.